Okay, welcome back. In the last video, we looked at how we could convert from binary, octal, or hexadecimal to its decimal equivalent. And now we're going to do the reverse process. So we're going to start with decimal numbers, and we will be converting them to either binary, octal, or hexadecimal. So let's get started. The proposal here is that I'm going to go through 6 examples in total again, and that you should pause and try every second problem on your own. Okay? So we're going to start with this one. This is 153, the regular decimal number, and let's go ahead and convert it to binary. So I'm going to show you how. If we want to express this number with a series of zeros and ones only, the way to do this is to repeatedly divide by 2. When you repeatedly divide by 2, there are 2 possibilities. Either the remainder will be 0 or it will be 1. Okay, so I'll show you here exactly what I mean. So we take 153 and divide it by 2. So if you need a calculator, that's fine. It's not a problem at all, okay? So you do this, 153 divided by 2. You know how it says 76.5 here. What you're going to write down, however, here is only the whole number part, 76. But since 76 multiplied by 2 would only be 152, we record a remainder of 1 in that step. And then you clear your calculator and you go again. So now you're going to take 76 and divide it by 2. Okay, now this time, look what happens. You get exactly 38. And that's because 76 is an even number. So in that step, there was no remainder. And then you can continue. Clear the calculator. 38 divided by 2. Okay, this is exactly 19. And again, don't worry if you have to use a calculator, not an issue. You write down exactly 19 and you record 0 for the remainder. Okay, continue. 19 divided by 2, however. So if you take 19 and divide it by 2, now you get 9.5. So you only write down 9. Only the whole number part. But since 9 times 2 is 18, we have a remainder of 1 in that step. Okay, clear your calculator, and then you would keep going, all right? You'd say 9 divided by 2. Well, that's 4.5. Just write down 4 and record 1 for the remainder. 4 divided by 2 is exactly 2. So there will be no remainder in that step. 2 divided by 2 is exactly 1. So there will be no remainder in that step. And finally, we take the 1 here and we try to divide it by 2. And of course, here the calculator would say 0.5 if you were still using a calculator. But we say that 1 is not divided by 2, so 0 times, and the 1 remains as the remainder. And that's because 0 multiplied by 2 is just 0, not 1. So the 1 that was here and is also here is now the remainder here. Okay, and now, when you write down your answer, it's really important that you record it this way, so from the bottom up. Now, this is a bad example of that because this is one of those numbers that reads the same in both directions, okay? Like the word level, for example, it reads the same in both directions. However, in general, we read these from the bottom up. So the number we would write down here is 100 11001. Okay, and we could put a little subscript of 2 to indicate that we've correctly converted to binary. So this is the binary equivalent of the number 153. Okay, and if you take a quick scan at these numbers here, every time they were odd, we recorded a remainder of 1. So here, there's the 1. Here, there's the 1. Here, there's the 1. And lastly, here. Okay, and anytime these numbers were even, of course, the remainder was 0. So here's a second example. And again, if you feel comfortable now, you could pause the tape and try this one on your own. You can take the number 360 and convert it to binary. So you may go ahead and do that. And in the meanwhile, I'll also solve it here. Okay, so 360 divided by 2 is exactly 180. So the remainder is 0. 180 divided by 2 is exactly 90. So the remainder is 0. 90 divided by 2 is exactly 45. The remainder is 0. But now, 45 divided by 2 is 22.5. So we write 22 here and we record a 1 as the remainder. 22 divided by 2 is exactly 11 with no remainder. 11 divided by 2 is 5.5. So we write the 5 here. And since 5 times 2 is only 10, we have a remainder of 1. 5 divided by 2 is 2.5. We write the whole number part of that here, the 2, and 1 is the remainder in that step. 2 divided by 2 is exactly 1, so the remainder is 0. And lastly, 1 divided by 2 is equal to 0. The 1 is left as the remainder here. And then we make sure when we write down the number, we write it down like this: 1011 01000. Just like that. And the subscript is 2. Okay, so the process is very similar when we're converting to octal and hexadecimal as well. So let's take a look at those next. Okay, so here we go. The next one I'm going to solve with you is starting with the decimal number 8,329, and I'm going to show you how to convert it to octal. So now the idea is, if we want numbers from 0 through 7 only, we can use repeated division by 8. Okay, so now for sure we're going to need our calculators. So we're going to take this number to begin with and divide it by 8. Every time we perform this division by 8, there are 8 possible remainders, and they are the numbers from 0 through 7 as required. Okay, so let's try this. Here's the calculator, right? 8,329 divided by 8. Okay, so what we do is we write down the whole number part only, which is 1,041. One way to figure out the remainder now is to just clear the calculator and say, okay, what is 1,041 multiplied by 8? 8,328. Oh, but we had 8,329, so that is a difference of exactly 1. So 1 is the remainder. Okay? So now you would do this again. You would take 1041 and divide it by 8. So let's try it. 1041 divided by 8. Okay, so we write down the whole number part, which is 130. Well, what is 130 multiplied by 8? It's 1040. It isn't 1041. So once again, in this step, there's a remainder of 1. Clear the calculator and try again. 130 divided by 8. Oops. Okay. Oh, so the whole number part is 16. Because it said 16.25. So what is 16 times 8? It's 128, not 130. The difference here is 2. So 2 is the remainder. Okay? And then you would continue. What is 16 now divided by 8? Is exactly 2. So the remainder in that step is 0. And lastly, 2 divided by 8. This is a decimal answer. So 0 times the 2 that is here and was here is now the remainder in this step. Okay, like here's what I'm saying, right? If you did 2 divided by 8, the whole number part is 0. So that's what we're recording here. This 2 is left as the remainder, and that's because 0 times 8 is 0. It is not 2. And then again, just read this up in this way and record your answer, 20211. And we can have a little subscript of 8 there to show that indeed it is an octal number. Okay, so hopefully you understood that way of determining the remainders. And perhaps you'd like to try this one now. Okay, so if you like, you can pause the video and try this on your own and then rejoin the video to see if you've done it correctly. Okay, so here I start with 5,000 and I divide it by 8. Okay, this is 625 exactly. So 625 with no remainder. And then I need to take 625 and divide it by 8. Okay, 78.125. So I write the 78 down right here. But 78 times 8 is 624. And so we have a remainder of 1 in that step. Okay, then we would do 78 divided by 8. The whole number part of that is 9. So I write down 9. But 9 times 8 is only 72. So 72 subtracted from 78 gives us a remainder of 6. Okay, then we would take 9 and divide it by 8. The whole number answer here is 1. But 1 times 8, of course, is only 8. So the remainder is 1 in that step. And lastly, we would take this 1 and try dividing it by 8. Of course, the answer here would be 0, and this 1 would be the remainder. Okay, so the correct octal equivalent for 5,000 is 11610. Just like that. Okay, so the last thing I'm going to do then is to show you how to go from a decimal number to a hexadecimal number. And I'm sure you've guessed that this is going to involve repeated division by 16 now. Okay, so we do those as the last two examples for this video. So let's go ahead and try this one, 3499 to hexadecimal. Okay, so I'll go through this with you. So we take the number and now we divide it by 16. Okay, so let's try that. I'll put the calculator up here now. So 3499 divided by 16. Take a look at the calculator display. So the whole number part here is 218. So that's what we write down. And now we need to figure out the remainder. So what is 218 times 16? It is 3488. And 3499 minus 3488 is 11. So we write down 11 as the remainder. And then we clear the calculator and try again. So we take 218 and divide it by 16. So let's try that. 218 divided by 16. And the whole number part here is 13. So we write down 13. But what is 16 times 13? It is 208. 218 minus 208 is 10. So the remainder in that step is 10. Okay, one more. 13 divided by 16. So, you know, we're going to be writing a 0 here. 13 divided by 16. So the part in front of the decimal is 0. So we're recording a 0 here. And of course, 0 times 16 is 0. And 13 subtract 0 is 13. Okay, so we stop when we have a 0 in this position. Whatever number was here is the remainder. And then all we would do is read this from the bottom up. But first, we should make note of the letters represented by these numbers. And so I remind you that those can be found in this little chart here. Okay, so we're looking at 11, 10, and 13. So 11 is B, 10 is A, and 13 is D. Okay, and then don't forget that we actually read these up when we go to write down our answer. So we end up with DAB here. Okay, so DAB is the hexadecimal equivalent of the number 3,499. Okay, and for the final example of this video, we're gonna take this number 2989 and convert it to hexadecimal. Okay, so once again, I would encourage you right here to pause the video, try this one on your own. Who knows, maybe it's another word as an answer. So go ahead and try it and then restart the video to compare your answer. Okay, so here's my solution. 2989 divided by 16 is, so I'm going to write 186 here, but 186 times 16 is 2976. So 2989 minus 2976 gives me a remainder here of 13. Okay, next, clear it. And I take 186 and I divide it by 16. Okay, there's my answer, 11.625. I only write the 11 down here. What is 11 times 16? It's 176. So 186 minus 176 gives me a remainder of 10 in that step. And lastly, if I tried to divide 11 by 16, I would have a 0 here. The 11 is left as the remainder here. Okay, I use the chart to write down that these correspond to the following letters. And to make sure that when I write down the answer, I write it down this way. So we end up with B-A-D or bad. Okay? So bad is the hexadecimal equivalent of 2,989. Okay, thanks a lot for watching. And take a look at the next video. In the very next video, we are going to be converting directly between octal and binary, and also hexadecimal and binary. So we will not need to go to the decimal number system in between those conversions, okay? So that will be explained to you very clearly in the next video. Okay, great. Have a nice day.